with. Make sure I'm recording this guy. There we go. Alrighty, so as you can see, they're asking us to find the approximate area. And as always, when you are working with circles, which they're not telling that here, but for the circle part of it, make sure you're using pi as approximately 3.14. So let's take a look at how we can find the area for this. So can you tell me what combination of shapes do you see in this figure over here? So, we've talked about squares, rectangles, parallelograms, trapezoids, of course, circles. So what shapes are you seeing in here? Okay, Terry, you talk about 2 triangles, a rectangle, and a semicircle. Very nice. Anybody else see any other shape other than what I just read out from Terry's response? So Terry said 2 triangles, a rectangle, and in a half of a circle, a semicircle. Okay, so let's take a look at this. So Terry, you're talking about 2 triangles. Of course, those are the edges that we are looking at, right? Which would become a triangle. So you can, of course, kind of see this guy over here is forming a triangle. And then if I drop another straight perpendicular line here, this would form a triangle. And of course, then what is left in the center would become your rectangle. And of course, you can then see there's a semicircle on the top. So let me ask you, of course, for the very bottom part of this figure, they are telling us it is 8.4 inches. And let me change the color here. So this is 8.4 inches, but then the radius of the semicircle is 2.6 inches. If we were to go ahead and get it all the way to the other side, what would that total length become at the top over there? What would our total length be on the top once you extend that out? Yeah, very nice, Michael Brooks, very good. So you just be taking 2.6 and you double it, which of course gives you the 5.2. So this would be another 2.6. And when you add the 2 together, you would end up with 5.2 inches. So since this is a rectangle, we could say this side also would be the same measurement, right? You could get 5.2 inches over here. So now let me ask you, out of 8.4, your 5.2 is going to be part of that rectangle. So when you do 8.4 minus 5.2, what do we get? Well, you should have 0.2 from here, and this would be what, 3? Now, how are you going to distribute that? Yeah, Brooks, very nice. How are you going to distribute that 3.2 between this guy and this guy? Terry, very nice. So Terry, you're talking about dividing by 2. Brooks, you said the same thing, but can we really divide by 2? Let me, do these really look like they are the same length on either side?
No, they look the one on the right looks a little bit like longer on the base.
Yeah, he does. This one looks a little bit longer than this one. So this is the longer side, and this would of course make it the shorter side. So we wouldn't really, because there's no other information being shared with us. We don't know what this measurement is, because you know that you can always fall back on Pythagorean theorem, right? If you know 2 sides, you can always find the third one using the Pythagorean theorem. But other than knowing that this side is 3 inches, which we would imagine if the center is a rectangle, this guy would also have, yeah, that's fine, Sabrina, would be 3 inches, but you still have 2 sides missing on both triangles, right? So we wouldn't really be able to guess what the measurement is going to be. So actually, in this case, you don't want to break it down into triangles and a rectangle. So what other shape can we go with out here if we cannot do triangles and rectangle?
Trapezoid.
There you go. That's what we need, because for a trapezoid, we do have enough information that we can work with. So I'm actually going to go ahead and clear some of this writing out, since it's not going to help us. Okay. Alrighty, there we go. So trapezoid, and let's see if I can find our formula for a trapezoid. So this is basically the kind of shape that we had. They're giving us 3 inches here. We know the top was 5.2 inches. Bottom was what, 8.4 inches. So using that, we can use this formula for a trapezoid and come up with the bottom half of our shape. And then of course, the top half of a semicircle. Then we can use the formula for a circle. And it's a semicircle. So, of course, you'd end up dividing it by 2 to find the area of the circle and put that together, and you would have your area for this shape. So that's what we're going to do. So these are the 2 formulas, like I said, we need to be using. So let's get back down to our image. Ah, there you are. Okay. So we have a trapezoid and we have a circle. So trapezoid formula was 1/2. Then you add your 2 bases together and multiply by h. Circle by itself is pi r squared, but again, like I said, this is a semicircle, so you can do half of the area of a circle. So I'm going to give you guys a couple minutes and let me see what your total area for this entire figure comes out to be. So just one answer, the area of the entire figure. And if you have any questions, put them in chat and I'll try and guide you through. All right, Brooks, looks like you already have your answer. Wonderful. And while you guys are doing that, I will go ahead and try and calculate this also. Okay, Sarah, you've got an answer. All right, very nice. Yeah, Brooks, Sarah, your answers are good. Terry, you just shared yours with me. So let's see, you did half. Terry, I got an answer slightly larger than that one for the trapezoid. So remember, you need to do the addition part first, because it's in parentheses. So add those 2 numbers first and then multiply with the 1/2 and then the height of the trapezoid after you're done adding. And I will go back and check my math because yeah, it should be larger, slightly larger than the number you have. Oh, still larger than that. I know. Does anybody else have the area of the entire figure over here, guys? I only have answers from Brooks and Sarah so far. Michael, very nice. That's correct.
Are we doing the whole thing with the half circle or just the trapezoid?
But both put together. Yeah, that's the
Oh,
answer.
that's why I'm lower. Okay.
Yeah. So your answer, even though you're only doing the trapezoid, should still be slightly larger for just the trapezoid part also. Destiny, Sabrina, any questions, or are you guys doing okay? Okay. So when you have your answers ready, let me know. Okay, Sabrina, that's fine. So remember, with the trapezoid, as I was just kind of explaining to Terry, you want to go ahead and add your two bases first. So of course, the upper base for the trapezoid is going to be, basically what forms the diameter of this circle here. So you can see that's where we had and that should be a 5.2. I don't know what happened to my decimal. So you're taking the top half, which is the 5.2 inches, and you're adding it with the bottom base, which of course is the 8.4, which is given to us. Sabrina, the number is fine, but this is area. So remember, that's only squares, two-dimensional, right? Volume is the cubed one. Yeah, okay, very good. Alrighty, and then the height of our trapezoid, of course, is 3 inches. So that becomes the height. This would be, I'm treating this as base 2. This guy would be base 1. So go ahead and multiply, add the numbers first, then do the multiplication. And that would give you the area for the trapezoid. And this one, I'm actually going to call it a semicircle. Is going to be, of course, pi. Remember, you're using the approximation 3.14. You're only doing the radius, not the diameter. So the radius is given to you as 2.6, and it's radius squared. So square that number and then divide by 2. And that'll give you the area of the circle, which this guy will be an approximate value. And then, of course, just add the 2 together, and that'll give you the area of the, very nice, Terry. I'm glad you were able to. So do you know where you were going wrong? Not sure?
I don't know. I must have just put it in the calculator wrong because I kept doing the same thing over and over, the formula. And I was like, why isn't it turning out? So.
Oh, I see. Okay.
I think it was just the way I was putting it in the calculator.
Okay. Alrighty. So that total should come out to be 13.6 when you add the two bases, multiply by 3, and this area will come out to be 20.4. And remember, this will be square inches because you're adding the two bases together. So that's just inch being added with inch. The multiplication happens when you are multiplying 13.6 inches with the 3 inches. So that's where that square inch value will come in from. And so this is for the trapezoid. For your area, you're of course doing radius times radius. So that's where the square inch will come from. And this guy will definitely be an approximate value. And he comes out to be 10.6132. And of course, this is square inches. So this is for the semicircle part. And of course, when you add the two of them together, you end up getting, what's that, 20, 31. Oh, let me see if I can find my. Yeah, 31.0132 square inches. So I'm kind of glad that, Terry first kind of started out thinking about, we do have two triangles and we can break it down into a rectangle in the middle. But then as we started breaking this down, we realized, well, the triangles, we don't have enough information to really get the measurement on the triangle. So then you could see it was actually easier to think about this more as, you know what, my bottom half of the figure is a trapezoid, the top half is a semicircle, so I can break it down into those two shapes and get my total area. So anyone have questions on this example here, guys? No, we're okay. All right, so let's save this. And for the next example, I actually wanted to look at something like this guy here. So let's make him a bit smaller so we can get the entire figure on my screen here. All right, so again, they're talking about approximate value. So as you can see, there is going to be a circle involved in this shape. So again, when you use the value of pi, you're going to be using 3.14. So can you tell me, in terms of a volume, three-dimensional figure, what are the shapes you are seeing in here? I'm seeing two shapes, but let's see what you guys are seeing. So what would be the two, you know, objects we're looking at? Sabrina, yeah, very nice. We have a cone and a cylinder. Destiny, you said pyramid and a cylinder. So actually, since your bottom surface is circular, it will be a cone instead of a pyramid. Pyramid usually means your bottom of the base should be a rectangle or a square. That's fine, Carrie. Hopefully with the formulas and stuff, you should be able to follow along. But if you have any questions, let me know, okay? All right, so let's take a look at what are our two formulas for a cylinder and the cone. So of course, at the bottom half, this will be, you know, this little section is going to be the cylinder. And then of course, you can see this is where your cone is coming at the top. So we are going to find the volume of the cylinder, and we will need to find the volume of the cone. All right, so I'm actually gonna go up so I can show you the formulas for this, guys. So cylinder, of course, you know, is a circle, and it has a height on it. And the reason I'm calling it that is because you're literally taking the area of your circle, because, you know, the base on a cylinder is going to be a circular base. So that means you take the area of a base, which is a circle, so that becomes pi r square. And then whatever is the height of your cylinder, you multiply it with that. So the volume of our cylinder is going to be pi r square h. Now, when we're talking about a cone, you know, it's still going to be the same thing, because the base of your cone is again going to be a circle. So you can see again, you have the area of your base, you have the height. So very similar to what we just looked at with the volume of a cylinder. So you still have pi r square h, but the difference is, you know, you start out with that broader circular base, but then you start tapering upwards on a cone. And that is basically, and you know, you can, I'm sure you can find videos and stuff explaining that, but basically the idea is it's reducing by a third of its size. So as you get, and you know, you get to the very tippy top of your cone. So that's why we multiply it by a factor of 1/3, because, you know, obviously a cylinder stays the same width for its entire shape, but in a cone, we start tapering upward. So that's where that difference kind of happens. So these will be the two formulas that we will need to use. So let's get back to our shape over here. Alrighty, so let's start out with the volume of the cylinder. So again, pi, you are using 3.14. The radius is going to be, you know, whatever the base of your cylinder is. So you're given 3 inches over there. What's going to be the radius for that guy if they're giving us 3 inches? It's a circle, right? Basically, that's what you're looking at. So what is the radius of that circle? Brooks, very nice. Yeah. So they are giving us the diameter, and to find the radius for this guy, Terry, very nice. Yeah, you're going to take the 3 feet and you're going to divide it by 2 to get your radius, which will of course end up giving us 1.5, and this will be square. And then of course the height for the cylinder is given to us as 8.1. So this is where you're basically doing radius times radius. So that's going to be feet times feet, which will give us the square feet. And then the height also is in feet. So the square and 1 more feet together, of course, is where the cubic calculation comes from. So this will be a cubic feet for the volume. So don't round your answer. I'm pretty sure you're going to get some decimals in here. So let's see what the volume of this cylinder comes out to be. And like I said, for now, we're just going to keep all of our decimals as is. And I'm already seeing some answers coming through. So Sabrina, I think you're actually going to end up with 4 decimal places just by looking at our numbers over here. So I would say keep up for the whole, all those 4. If you come up with 5, keep all of those decimals for now. Yeah. All right, Michael, I see your answer and you shared it for the entire shape. I was just asking you guys right now for just the cylinder. Sarah, very nice. Brooks. Okay, so Sarah, I'm comparing my answer with yours and looks like you are shy by almost 20 points. Brooks, Destiny, I'm looking at your guys' answer. Yeah, Destiny, that looks good. Brooks looks good. Michael, that would be great. Yeah, very nice. Terry, very good. Yeah, so we are basically taking, Sabrina, very nice. You're basically taking 3.14, you're multiplying it with 1.5 into itself twice and multiplying it with 8.1, right? So those would be the 4 numbers that you multiply together, and that should end up giving you, as you guys have, 57.2265. And this will be, like I said, in, okay, yeah, Sabrina, I see your answer. That's good. 2265. And as I said, this will be in cubic feet. And this would be the volume for the cylinder part. Okay, so Sarah, you are taking 3.14. And then you're taking 1.5 to the second power. So that actually comes out to be 3.14. And then you take 1.5, but you write it out twice, and 8.1. So you're multiplying all 4 of these numbers together. And that should end up giving you the 57.2265. Okay, all right. Oh, you didn't square the 1.5. Okay, got it. And that's pretty much the same thing that's going to happen over here, guys, with the volume of a cone. But, of course, your measurements change a little bit. So for this guy, we have 1/3. Pi will, of course, be at 3.14. And then the radius, obviously, you can see this guy also has the same base as our cylinder. So for the radius here, we are still using 1.5 squared. The only difference is the height of the cone is different, right? Because the 8.1 was the height of the cylinder. What's the height of the cone? So what will we use for the height of the cone? Yeah, Brooks, perfect. Sabrina, very nice. They're telling us that because you can see the height of the cone goes from the tippy top to the base, and that comes out to be the height for your cone. So this will be then multiplied by 3 inches. So honestly, pretty much the same calculation, except you are replacing the 8.1 with 3 feet. Yeah, Terry, very nice. So again, guys, you are taking the radius squared. So that's going to be square feet. You're multiplying by a height of 3 feet. So that would be the third portion where our feet is coming from. So 1/3 3.14, 1.5 to the second power, multiply by 3, and this will give us our cubic feet. All right, Sabrina, I see your answer for the cone. Very nice. Let me make sure I haven't calculated that part yet. So we're multiplying by 3. Now, you know, the other thing you guys can, of course, do, Terry, we want to leave the 1/3 as it is. You don't want to round that. So that's what I was just about to say. Take your 3.14, multiply with the 1.5 squared and 3. Get that answer first and then just divide it by 3. And let's see, I've got Sabrina, Michael, those answers look good. Brooks, very nice. And so this guy is coming out to be, oh, I'm actually gonna put it right here. So I've got 3 of you that gave me the answer, and this comes out to be 7.065, which we know is going to be smaller because this guy is not as large as the cylinder. And then, of course, for the volume of the entire shape, you know, go ahead and add these two answers together. And Brooks and Michael, you guys have already shared that answer with me. So let's see, I've got Brooks's answer. Brooks, that looks good. And then Michael, let me go find yours. Yeah, very nice. Michael, the answer you had shared initially, that also looks good. Yeah, Sarah, Terry, very nice on your cone volume. Sabrina, are you using the calculator based on Desmos or the GeoGebra? Because I know I'd shared 2 different calculators with you. Desmos, yeah, that's a good way to work with that Desmos calculator. Very nice. Yeah, Sarah, that's exactly what you're going to do. So you're going to take the 7.065 and add it with the 57.2265, and that'll give us the entire object's volume. Terry, that answer looks good. That's okay, Michael, no problem. Remember, I did that on Monday to you guys. I keep forgetting to charge my laptop and then, you know, my battery runs out, so you're completely fine. Destiny, that looks good, very nice. So yeah, when we add these two numbers together, Sarah, perfect, 64.2915. And again, this is volume, so it's going to be in cubic feet. And that's going to be the volume of your entire, I don't know, to me it looks like a crayon, but you know, whatever that shape might be. Questions on this example here, guys? So we're going to do the exact same thing, but now we're going to throw in dollar amounts, basically. You know, we're going to throw in money and basically say, you know, okay, if you were trying to, let's say this guy was, you know, obviously it's a pretty tall structure. So, you know, if you were trying to fill this up with something, well, you know, how much quantity of, you know, I mean, if this were a silo, which silos have more of a, you know, hemisphere kind of thing on the top instead of a cone. But if you were filling this up with grain, you know, how would you, you know, what quantity would it take, which is what the volume would tell us. But then, you know, if we knew what the value is, we could go ahead and calculate a dollar amount for that. So that's kind of what we're going to be doing next. So let's clear this out. So if you actually go to your reading section, this is what I was talking about, and you click on this handout, you are going to see a file that looks something like this. And then you will see there's a link for a Google Sheets file here. And if you click on that, it should take you Yeah, Sarah, exactly. The cost estimation supplemental handout. Yeah. But let me go ahead. So you can go through that handout, or I'll share the link of this file with you through chat here. So all of you should see that link coming through on your Zoom chat. So it's basically the same questions, but again, I just put them in a spreadsheet so we could work through them. So you can see some of these are going to be, area type of questions. Some of these are going to be volume type of questions. So these are the same questions that you have in your handout that I have included here in our Google Sheets. So let's take a look at, what we need to do for these examples here. So this guy is talking about question number 1. And, again, we want to try and get you guys feeling a little bit comfortable with Excel or Google Sheets. So that's kind of why I've transferred these here. So the first question is asking us, we have an exterior paint which cost $31.40 a gallon. So I'm actually going to go ahead and put that amount over here. So it's $31.40. And since this is a dollar amount, I'm going to format it, and you can see the little dollar symbol here. So we can go ahead and do that. So we know this is a dollar amount. And they're telling us this 1 gallon of exterior paint is going to cover 44.4 square yards of, surface area. So they're asking us to find the cost of painting 2 sides of this figure below. And of course, by 2 sides, we mean, if this was like a door or something, we want to do the front and the back of this door over here. So the idea is we're basically trying to figure out how much it's going to cost us to paint this figure. So if you're applying paint, what calculation are you doing? Are you finding perimeter, area, or volume? The 3 calculations that we talked about. What do we need to do here?
Area.
Yeah, very nice. Because obviously when we talk about paint, we're talking about covering the entire surface, right? Which means the whole door. And I'm calling it a door because I don't know what else to call it. Terry, very nice. Yeah, so you're going to be painting the front and back, which means you do have to find the area for this. So that's what we're going to be doing, is calculating the area for this shape. So now the question is, how do you calculate the area for this figure? What shapes can we break this down into that we're familiar with? Perfect. Yeah, very good. So we will have a triangle and a rectangle or a square were the 2 answers I came up, you guys sent me. So of course we need to go ahead and separate this guy. So if you look at the measurements on the left-hand side of our figure, they're telling us the length is 7 yards and the width is 6 yards. So that would be this guy also, right? He would be 6 yards. So yeah, that does come out to be a rectangle. And then of course, we've got the measurements for our little triangle over here. So let's break this down. We're doing area of a rectangle and a triangle. Okay, so for the rectangle, what does it come out to be, guys, the area? Oh, I didn't mean to do that. Okay, looks like you guys have answers. And then go ahead and tell me for the triangle as well, guys. Very nice. So for your rectangle, of course, the dimensions on our rectangle are 7 and 6. So you are going to take 7 multiplied by 6. So as you can see, that will come out to be 42, which is what you guys have. And this is going to be square yards. And then for the triangle, what did you guys have? Okay, Terry, you've got 25. Sarah, you've got 15. Brooks, you had 12. Okay, Brooks, you also gave me your 54 for the whole shape. Okay, we'll wait on that answer for a minute. And then Michael, you had 12. So I've got 15, 12. Okay, Terry, you've amended your answer to 15. So let me ask you, okay, so two different answers. Let me ask you, what calculation did you guys use on the triangle? Because, you know, we're obviously getting a difference of 3 units. You've got 12 and 15. Half times base times height. Very nice. Terry, you did 6 times 5 divided by 2. Sabrina, did you mean 150 or 15? Okay, Michael, you did 6 times 4 times 2. Okay. So definitely I can kind of see how you guys have a different approach in finding that triangle. So let's talk about that. Okay, Sabrina, I see your answer. So if you look at our triangle, and then if we just turn it the right side up, this guy is telling us this side is 5 yards and this is 5 yards. We know this guy is 6 yards. Now the area of a triangle, as you mentioned, is 1/2 base times height. So of course my base is going to be 6 yards. But then what's my height? The 5 is not the height of our triangle. Remember, the height would be that perpendicular distance that goes from, you know, the tippy top to the base. Okay, Sabrina, I see that. So this is where actually this 11-yard calculation will come into play. Now we know out of those 11 yards, 7 is going to be the, you know, the part of the rectangle, which will of course then leave us with 11 minus 7, which gives us what? Yeah, very nice. So 11 minus 7 will of course give us 4. And that's what this distance here is going to be, guys, which is going to be the height of your triangle. So this will actually be 4 yards. And that's what your height is going to be. So yeah, those of you who gave me the 6 times 4 divided by 2, you guys were definitely on the right path, because, you know, that would be 24 is 6 times 2. 6 times 4, and then divide that by 2 will give you 12 square yards on the area of the triangle. Let me know if anybody still needs a clarification on this, if you did not understand how we did this. So we're going to do 1/2, and I'm just going to type that in as a fraction, but put that in parentheses. Multiply by my base of 6, multiply by my height of 4, and you will see that's where our little 12 comes from. And again, this will be in the measurement of square yards. So everybody comfortable with how the triangle area came out to be? Yeah. Alrighty. So once you have those two shapes taken care of, and I'm just going to clear this out for the total area of our figure, and Brooks, you had already shared that answer with me. Michael, very nice. Will of course just be a total of the rectangle and the triangle areas added together, right? So again, here I'm going to do equal to, click on my cell for 42 and 12, or remember, you can also use the sum function. So whichever one you're comfortable with, you will get your total measurement here. Yeah, Sabrina. And so, yeah, sometimes it's just, you know, you kind of have to look at what information we have available and kind of go based on that. But once you kind of go through an example, then next time you will know to keep an eye out for it. So this here gives us our total area. And, you know, of course, this is the portion we're really interested in. And for now, we're just going to color it so we know that's the information we need to use. So now you have your area, guys. We know it's going to be 54 square yards. This is where the final question of how much will it cost us to paint the front and the back of this image. So total area is just for one side, right? Now we have the front and the back. So what will we need to do with that 54? So the 54 is just for one side of your, as I said, I'm calling this guy a door. So what is going to be your front and back put together? Very nice, Terry. Yes, double it, because you will need to paint the front side and the back side. So we're going to do 2 times the 54, and that's how much. Oh, I didn't put an equal to here. What did I do? Okay. 2 times 54, and you can see that's going to be the surface that we're going to need to paint. If your 1 gallon of paint will cover 44.4 square yards, basically how many cans of paint are we going to need? And how do we figure out, you know, how many cans of paint do we need? So the total surface area we need to paint is 108 square yards. Each can or each gallon of paint will give us 44.4. Terry, that's wonderful. Yeah. So what you do is you take your 108 and you divide by how much paint, you know, 1 gallon will cover, or how much surface will 1 gallon cover. So for your number of cans, number of cans of paint, you know, we're basically going to have 108 divided by your 44.4. Very nice. Yeah. But, you know, obviously, since you are getting a decimal answer, Terry, like you had in your answer, we obviously cannot buy 2.4 gallons of paint, right? I mean, if each can is 1 gallon, then we are going to have to buy 3 cans so that we can get 2 gallons plus a little bit more. Now, you know, if they were going to able to give you exactly the quantity that you want, then yes, maybe we could do something about that. But if we don't know, you know, that's possible. That obviously means then you're going to round up this answer, and you will end up buying 3 cans of paint. And if you are buying 3 cans of paint, then how much will that dollar amount come out to be? Now, if you think you can get exactly, you know, 2.5 gallons or 2.432 gallons from your paint store, then you can calculate the cost based on that. If you think, you know what, we're going to have to go up, then you're going to have to calculate the cost based on that. So we know, just to kind of show you how this would work, you would take your quantity and you would multiply it by your dollar amount, right? So that would come out to be $76.38. However, if we had to buy 3 cans of a gallon each, then of course your cost would go up. So it would depend on basically what the quantity we are able to get. I would probably use this as my final answer. Questions on this one, guys? So you basically identify, do you need to find the perimeter, area, or volume? Once you know what that measurement is going to be, look at your figure, try and decide, like we did here, it was a rectangle and a triangle. We came up with our total area. And once you have the total area, in this case, since we were painting the front and the back, we ended up doubling the total area, which is where our 108 square yard came from. And so once you had that, then of course we knew each gallon is giving us 44.4 square yards of coverage. Take that, figure out how many cans of paint you need. And once you have that value, you can calculate what your total dollar amount was going to be. So our final answer, remember, is the dollar amount. That's what we're interested in. Because that question was, what is the total cost? So in this case, I would say our total cost was $94.20, and that becomes your answer. Okay, before we move on to the next example, any questions on this one, guys? No? Okay. So this one here is now talking about glass is $43.30 a square foot. How much would it cost to put glass in the Norman window below? So same question, do you find perimeter, area, or volume? If we're putting glass in this Norman window. Perimeter, area, or volume? Terry, yeah, very nice. Because, again, when we're talking about glass, the glass is going to cover the entire surface. You're going to have glass in here. You're going to have glass in here, right? Which means you're again covering the whole entire shape of this Norman window. So again, we are finding the area. Now, what are the two shapes we are looking at here, guys? And I'm going to actually go ahead and put these numbers here again. All right, let me see what you guys have. Very nice, a rectangle and a semicircle. Very good. So again, we will need to find the area of the rectangle. And of course, of the semicircle. All right, let me see what you guys have as the area of the rectangle this time. Michael, very nice. Cherry, very good. So of course, the rectangle would be this shape over here. So of course, you can see our length is going to be 8, width is going to be 5. So you end up multiplying 8 times 5. And this is in feet. So of course, this guy will come out to be square feet in our unit of measurement. What's your area just for the semicircle? Okay, Michael. And remember, again, for pi, you guys are using 3.14, or with the spreadsheets, you can actually type in pi in there. So you can do equal to, and if you type in pi, it will use that as your, automatically give you the approximation. So I see Michael's answer for the semicircle. What about the rest of you? Terry, very nice. Brooks, very good. Yeah. So we are taking pi for the 3.14. Now, of course, as far as the radius of your semicircle goes, that would be, from the center to the edge. So of course, that's going to be half of 5, which will come out to be a radius of 2.5 feet. So remember, your area of a circle is pi r squared, but then since this is a semicircle, you're going to be dividing it by 2. So that means this guy will come out to be pi times, and then in parentheses, I'm going to go ahead and put 2.5, raise it to the second power. Terry, I see your answer. Very nice. And then basically, we're going to divide this by 2. Okay, and looks like it didn't like the divide by 2, so I'm just going to go ahead and multiply by 1/2. Is it the pi that it's not trying to recognize? Okay. All right, I will play around with that later on. I'm just going to go ahead and type in 3.14 for now because I want to move forward. Okay, so Terry, you gave me your total area. So let's go ahead and see that. As you can see, since you had 40 on the rectangle and 9.8125 on the other one, of course, our total is going to be these two guys added together, which of course will give us 49.8125. Michael, very nice. Now this one, of course, you are only putting the window on one side, and obviously it will have the effect on both sides. So unlike the previous example, we don't have to worry about, doubling this number or anything. This is going to be our total area. So can you tell me now, what will our cost come out to be for the window, the glass, sorry. They're telling us the glass is going to be $43.30 a square foot. So what does your total cost come out to be? And since this is a dollar amount, of course, we want to stay at 2 decimal places. Terry, I see your answer. So the square footage for our window is coming out to be just shy of 50 square feet, right? 49.8125. Michael, very nice. So all you will do here is, again, take your square feet and multiply it by, again, the dollar amount, because that gives you 1 square foot at 43.30. And then once you convert it to a dollar amount, you will see it comes out to be $2,156.88. Now, if you just type in these two numbers in your calculator, it will give you 2,156.88125. But, obviously, like I said, since this is a dollar amount, round it to 2 decimal places, and you should have just 0.88 and nothing else afterwards. So this ends up becoming your total cost. And that's the answer we're looking for, the $2,156.88. Questions, guys? Okay. Now, this third one is kind of interesting because you will see we have taken a circular pool. We put a concrete sidewalk around it, and then it's surrounded by a grassy area. So from the image, you can kind of make that out because they're giving us labels on that. But then let's look at the information they're sharing. So they're telling us we have a circular swimming pool, which has a diameter of 50 feet. They're telling us it is centered and fenced in a square region, which is measuring 80 feet by 80 feet. So you have a square, think about it as a garden or a backyard, which is basically 80 feet by 80 feet. And then they're telling us we have a concrete sidewalk, which is 5 inches wide, that encircles the pool. So our sidewalk is 5 feet wide. And of course, everything else that is remaining is your grassy area, your garden region. So they're telling us sod is costing us 858. And of course, that is dollar amount, and that's going to be for each square foot. And I do actually want to leave it as 858, leave it at 3 decimal places. So so what I did was, let me show you. So when I typed my answer in and I clicked on my formatting to format it as currency, obviously it's going to automatically put it in 2 decimal places. But then I went to my little decimals over here and I wanted to increase my decimal place. So I just clicked on one of them. So my 3 decimal places would show up. So that's the price for our sod. For the fence, they are charging us basically 70 cents. So you've got 0.70 for each square foot. And again, I'm going to change that to a dollar amount. So these are all the dimensions that are given to us. So obviously, if you're talking about sod, you're only going to put the sod in the grassy area. And then the fence is going around the grass. So to find I guess in this case, let me ask you first thing, where you're putting the sod, what calculation will that be? Perimeter, area, or volume? So for the place where the sod is going to be laid. Michael, go ahead.
Area.
Yeah, so for the sod calculation, we are looking at area. Terry, very nice. Yeah, exactly. So we need to find for the sod region is going to be area. Yeah, no problem, Destiny. We're just going to discuss this example and then we'll be done. Okay, so sod is going to be area. Now let me ask you, for the fencing, what your calculation is going to be. Perimeter, area, volume. Brooks, very nice. Exactly. Very good. So the fence is going to go around the grassy area. So the fence is going to be a perimeter calculation. Okay, so let's get back to the sod question. What is going to be, and Terry, I do see your answer. And you guys are getting that from what calculation? How did you get your answers, Michael, Terry? Yeah, for the fence. I figured that's what you guys were giving me. Yeah, so you are basically talking about the perimeter of this little circular area, right? I'm sorry, square area where the grass is going, because they're telling us we are going to be putting the fence around the grass. So that's going to be this basically area or region, sorry, where you're going to be putting the fence on. So we know this is 80 feet by 80 feet. So, and being a square, we know all 4 sides are going to have the same measurement. So your perimeter is basically just going to be a total of those values. Yeah, Michael, Terry, very nice. 80 times 4 will give you the perimeter. So this is going to be 4 multiplied into 80. And remember, this is going to be in square feet. Yeah, and then to find the cost of the fence.
Is it square feet on the perimeter or is it just feet?
Oh, thank you. Yes, this is just perimeter, isn't it? Thank you. Yeah, very good. And then let me see. Terry, you gave me the cost. Okay. So in this case, they're telling us it's 70 cents a square foot. Now that's kind of an interesting measurement because I was looking at Home Depot's website to kind of see, you know, how they were charging for fencing. So usually they will actually tell you, depending on, you know, are you getting a section of the fence or are they going to be individual slats kind of thing? So they will actually give you the 3 dimensions. So they'll tell you how thick each piece is, then they'll give you the length and the width. So that's kind of where the square foot is coming from. But, you know, in this case, you're just looking at, you know, basically how many feet of fencing you're going to need. So you are going to obviously take your 320, which is the linear distance that we have, and multiply it by the cost of your fencing, right? So that will be the 320 multiplied by the 70 cents, and that should be a dollar amount. So you can see that comes out to be 224. So that'll be our final answer, which goes in here. So this was, you know, pretty straightforward calculation, and that takes care of our little perimeter question. Now, Sabrina, why are you getting only $2? Because that would be awesome, right? If you only had to pay $2 for 320 feet of fencing. I don't think we live in that world anymore, sadly. Okay, so like I said, the fence was the easy calculation. We're done with that. Now, how are we going to calculate the sod area? Because, you know, you have to think about, well, I'm not going to put sod on top of my swimming pool or the sidewalk. So how do we calculate that area first, guys? Okay, Michael, you want to tell me how you did the math there? Okay. Yeah, Terry, very nice. So we do start out with the area of the entire square as it is. So let's break this down. We're going to do the square part first. Very nice. Yeah, Brooks, very good. So let's do the square. Why is this guy not letting me type? There we go. So for the square, you're obviously just going to do 80 times 80. And this will definitely be square feet. Then we need to find the area of the pool. And what measurement did they tell us for the pool over here? The diameter of the pool is 50 feet, right? So if the diameter is 50 feet, what is the radius then? Yeah, very nice, Sabrina. Very good. So the radius is basically going to be half of the diameter. So again, for the area of, and this is just the pool, we're not including the sidewalk in there for now. The pool is going to be, which, you know, actually we could include the sidewalk. All right, area of the pool is going to be pi 3.14 times your radius of 25. And remember, it's radius squared. So it should be 25 times 25 times the 3.14. Yeah, Michael, that's kind of what I was thinking after we talked about the pool. So now they're actually telling us that the pool is also surrounded by a sidewalk, which is 5 feet wide. So if you think about this, our diameter of the pool is 50 feet. And then you are surrounded by a sidewalk, which is 5 feet wide. So that's actually telling you this little section here is 5 feet. And this little section over here is also 5 feet. So if we think about the total distance of, the pool, including the sidewalk, so if we actually did pool with the sidewalk, then actually you are looking at a total diameter of, and in that case, what I would do is, let me erase this for a second here. So if you did pool and sidewalk and you did the total diameter in that case, well, in that case, you're looking at 50 plus 10, right, for each side, and then take its half and you get a radius of, obviously 30. And if you calculate your area again based on this new diameter, then it will actually tell you what the area is that's going to be the pool plus the sidewalk. And that will be easier to work with than do the pool separately and, do the sidewalk separately. So with the pool and the sidewalk, you want to kind of go ahead and add those two together. So again, take the diameter of the pool. On each side of the pool, you have your 5 feet and 5 feet of the sidewalk. So that actually makes the whole thing 10 feet longer. So 60 is what we end up getting. Taking half of 60 will give us the radius, which comes out to be 30 feet. And then based on that, you should be able to calculate your pool plus sidewalk area. And in this case, you of course end up subtracting the two values. Yeah, so basically, Sabrina, if you're just thinking in terms of radius, then you're taking 25 feet as the radius of the pool and then adding 5 feet of one side of the sidewalk to it. Yep, and that will also give you the same measurement of 30. So our sod area where we need to lay the sod is actually going to end up becoming the 6,400 minus the 2826 that we have for the pool included with the sidewalk. Very nice, Terry. Perfect. And since we are still talking in terms of area, this is still going to be square feet. So this is the value we are interested in. So now let me ask you for the cost of the sod, what is it going to be? Terry, all right, I see your answer. Okay, so for the sod, we know they are charging us basically almost 86 cents, but like I said, we wanted to keep it at that 3 decimal places. So 0.858 is what they're charging us. And that's based on per square foot. So since our square feet is coming out to be 3,574, multiply that with your 0.858, and that should give you what your dollar amount is going to be. Now, this number, guys, we will definitely convert this to 2 decimal places. So I'm going to go ahead and decrease my decimal by 1 place. So it will give us just $3,066.49. And that's going to be the cost. Oh, sorry. That will be the cost of purchasing sod. Yeah, very nice, Michael. Terry, very good. So questions on this example here, guys. So take it slow, don't rush through the calculations, take it step by step, because a lot of your homework problems are going to be very similar to these ones over here. So as you can see, you know, if you can just break it down piece by piece, you should be able to come up with your final cost. Now, calculating the cost, honestly, is not the big part. It's coming up with that area or perimeter or volume, which is going to be a big part of your calculation. So we're going to stop right here. We've got a couple more examples. We can tackle those on Monday. As I was saying, you also have a homework assignment based on this. It will take you to this worksheet over here. Let me just clear this out very quickly. Okay. So your homework worksheet is going to look very similar to the examples we're doing right now. So, you know, some of those will just be a different shape or something very similar. So you can see your first three examples are very, very familiar to what we just did with the examples in class. So hopefully you guys can start looking at this. If you have any questions, you know, obviously I can answer them through email or on Monday in class, but keep working on those. Remember, you are submitting your application of percentages homework today. And Sabrina was looking at your, yeah, so the total area for the sod does come out to be 3,574. And you're actually going to multiply it by 0.858. So don't round up that answer, just keep it as what they're telling us in the problem. So your sod cost is 0.858, and that's what you multiplied by. So the moving the decimal was I was talking about here. So when your raw answer, you multiply 8.8558 into 3574, it actually gives you 0.492. So instead of keeping 3 decimals at the end, you want to round it to 2 decimal places. So I'm not moving the decimal, I'm just reducing the number of decimal places. Because, you know, when you're talking dollar amount, you want to leave it at 49 cents instead of 49 and then another 2 at the end of it. So we're not moving the decimal, we're just reducing the number of decimal places in the final answer. No, that's okay. No worries at all. Alrighty, guys. So we'll pick up the last 3 examples on Monday. If you have any questions, I'll be happy to answer them. And if not, then I will see you guys on Monday morning. Just please don't forget to submit your application of percentages if you haven't already done that. All right, everyone. Have a wonderful weekend. Stay safe, everyone. Terry, good luck to your son. You guys be careful, and I will see you on Monday.